intro, I would say let's kick this off. Looking forward to this amazing presentation. And yeah, welcome, Greg, again. And happy to hand over to you. The floor is yours.
Wonderful. Thank you very much. Let me share screen, my slides. Hey everyone, my name is Greg DeArmond. I lead Palantir's production infrastructure engineering group. And today I'm going to be talking a little bit about Palantir's journey with GitOps and things we've learned along the way and sort of how our approach has evolved and changed. So I've been at Palantir since 2011. Since about 2015, I've been leading our production infrastructure engineering group, and I currently live in Seattle, Washington, although Palantir is sort of a global company. I'll do a quick intro of Palantir and the infrastructure of Palantir, give a quick overview of like GitOps at Palantir, what the use cases are, and things like that. And then I'm gonna spend most of the time talking about our like 5+ year journey of trying to scale GitOps in production at Palantir. And we sort of reached this inflection point in August of 2020, and I'll talk about like what led up to like us sort of changing our approach and what we did, so what we've been working towards since then, as we like rethought GitOps and why. And then happy to answer questions at the end. Palantir, for those who aren't familiar, we're a company founded in 2003. We build software to enable data-driven operations and decision-making. We have two primary platforms, Foundry and Gotham, and then since the beginning of 2022, we've also been selling our Apollo platform, which is it's basically the DevOps platform we built in-house that powers both Foundry and Gotham for our company. We started making infrastructure and platform engineering investments back in 2015. In 2017, we rolled out sort of the production use of GitOps as we rolled out our Apollo platform across our customer-facing environments. And then today we have more than 100, 4 to 12 person engineering teams that are building and shipping and releasing and then operating somewhere like between 500 and 600 services across our Gotham and Foundry platforms. And those services get deployed across more than 100 production environments across the world, everything from the hyperscalers, classified cloud environments for the US government, on-prem environments around the world, and then sort of increasingly things at the edge where you have oftentimes mobile vehicles with intermittent connectivity and so forth. And across all these different environments and services, we do like thousands of deploys and configuration changes and so forth a day using GitOps and Palantir's Apollo platform. From an infrastructure standpoint, we have two teams that I'll sort of talk about today. The first is our production infrastructure group that I lead. It's about 110 software engineers and DevOps engineers and operators who are responsible for both building everything from like our cloud infrastructure to the Apollo platform that manages our software and basically all the tech we use to deploy and operate our customer-facing software platforms. We also have an internal infrastructure team. It's 10 to 15 engineers who are responsible for building first-party software, but also operating third-party software that really keeps our company running. So everything from like our developer tools like GitHub and CircleCI to the financial tools in Salesforce and all the things that sort of like a modern company needs to operate. We have three main use cases across the company for GitOps. The first is our continuous deployment and service management that we use Apollo for, that is focused on like how do we actually like deploy and manage the services that make up our customer-facing platforms. The second one is GitOps for our infrastructure, so the cloud infrastructure and basically how do you get to Kubernetes where we can actually deploy software on top of it. And then the third one is internal infrastructure, so it's how do we actually manage the developer tools and things like that. I'm going to spend most of this conversation focused on the first category, and I'll sort of make references to the other two and talk about why as I go. So when we set out on our journey sort of across these three different use cases, we had a shared set of principles that led us to want to use GitOps, but pretty different requirements. And so, in addition to like GitOps being in this sort of approach and tech that powers it being a very easy thing to get started with, which I think is like oftentimes why engineers like GitOps, we really like the idea of having a declarative single source of truth that has a full auditable history that you get with something like Git. And then, at Palantir, we operate our software in highly regulated environments, everything from like, governments to like highly regulated industries. And so, having a secure approach to change management for our production environments is really important. And we found a lot of the concepts and approaches and tools that are used in GitOps really fit our requirements. So everything from like MFA to like granular like RBAC and permissioning strategies to a lot of the tools that we wanted to use and could get started with quickly. The use cases that have pretty different requirements for what we were looking at though. So, for our continuous deployment and sort of service management, we had a central team that owned our Apollo platform at the time, and then they were the ones that were building out a lot of the GitOps machinery. But this was very much like a platform use case. So we had many, many users across the company who had very different goals and concerns. So everyone from developers of the software to operators, SRE folks. Also our InfoSec team plays a very active role in how we deploy and manage software, as do our compliance folks. And so like there was a lot of like, the different use cases sort of had to be accounted for across those different teams. For the production infrastructure, like cloud infrastructure and Kubernetes use case, it started off as a single team who were responsible for both building that out and operating it. And this use case got started maybe a year after the first use case did. And when they set out to do this, they really designed to have consistency across the environments that they were going to operate. And we're very intentional about limiting the surface area that users were going to be able to configure. And in doing so, it created a pretty different set of requirements that allowed them to approach the problem in a different way. And so before I get into the meat of this, one of the things that we found as we went through our journey was, GitOps and a solution, like your solution for GitOps, really needs to take into account your organizational structure and what your organization looks like and your use cases. And then one of the like most important decisions that will influence your experience is like your decision around how you're going to structure your repository. So I'll quickly touch on what that looks like at Palantir. In terms of roles and responsibilities, we deploy hundreds of different production environments. Each environment has an operational team who's responsible for that environment. And they're the ones who are sort of responsible for the overall health of the environment, but also who get to define like the rules of that environment. So when changes can happen, what their like compliance requirements are for that environment and so forth. We do have a central operations team at Palantir we call production, or we call baseline. They're our production engineering team, and they own most of, but not all of the environments. And then in addition to the environment owners, all of our engineering teams who are building the services and applications are also responsible for operating their software across, sort of like all environments they can get practical access to. So like obviously not the classified ones. And what operating means for us is, they're responsible for managing the configuration for each of their installations across the environments, for the release cadence that they want to release their software on, the upgrade cadence, the rollout strategies across those environments, but they're also responsible for monitoring and alerting and sort of responding to incidences for their software across the environments they're responsible for. And so given those roles and responsibilities, when we set out to sort of define a repo structure, we decided to go with a one repo per environment, where environment, when I talk about environment, what we're really referring to is sort of think of it as a single VPC and Kubernetes cluster, where we deploy sort of a full copy of our platform into. And each of these repos has a single file that defines all of the services and software that should be running in that environment. And then it has one file per service that has configuration overrides that the team who owns that service should be able to change. We also have a central repository that basically governs the repo structure of the other repos and things like permissions, permissioning models and so forth. And we have a bunch of automation that's driven off of that central repository that can kind of controls the others. Here's some information on the tech stack we use. I'm not going to get into too much detail for it, but in case you were interested, I put it there. So we've been doing this since 2017. We started off, I think, probably like April of 2017. And it's now it is the only way in which we manage production software at Palantir. And our growth, both as a business, but it's also its adoption over the years, has really grown quite a bit. So a couple graphs I'll just like walk through real quick. The top left shows sort of the growth of repos and therefore environments that we were using GitOps to support. I think at the end of 2021, we had sort of crested above 400 different environments that we use this for. And as both the environments grew and the complexity of our software grew in terms of the number of services and so forth that we were managing, so did the pull requests to the Git repos to manage the software. And so what you see here in the blue is essentially the number of pull requests on a monthly basis that individuals were opening. And in the pink were the number of pull requests that automation was opening. And so what I mean by automation is if an engineer wants to add a new service to the Foundry platform, they can use some automation we built that will open a pull request for every environment that Foundry is running in to add that service. And so with, if you have hundreds of environments running Foundry, that means you're opening hundreds of pull requests. And I think every month in 2021, we had more than 10,000 pull requests merged across our GitOps repos for the production use cases. And so as this happened and as our usage of GitOps scaled across our organization, one of the big problems became this thing that started off as this massive accelerant for our company because all of a sudden we had all this automation, allowed us to move much faster, allowed us to manage the scale much easier, started to become a burden. And so the graph on the right shows you the average number of hours it took to merge a pull request for our GitOps repos. And the blue line is, again, the sort of non-automation driven PRs. These are PRs that are opened by an individual for a specific reason. And then the pink line is the number of pull requests that were open, or sorry, pull requests that were opened by automation and the amount of time it took. And so from, after 2018, it was, the blue line sort of hovers between 20 hours and it sort of crests at 60. And we're talking is like more than a day, but less than 3 days to have a PR turnaround. That alone is not great. Pink line is pretty much above 140 hours or right around 140 hours for a lot of it. And with that, we're basically talking at 140 hours, it's an entire business week. And so this became this thing where we had to start making active investments in order to continue to improve the efficiency of our GitOps usability because, we had people who couldn't get anything done because they were waiting for pull requests to merge. And so what this led to is over time, we made a number of very concerted investments and could we do more automatic approvals of pull requests? Could we reduce the number of pull requests that you have to open? Could we restructure the Git repo structure so that these things were easier to manage and so forth? And so the green box in 2019 sort of represents where some of those investments had first shipped, and you sort of see the number of that's sort of the average time to merge the PRs crest at right around 60 and then go down a little bit. And then problems started creeping back up later in 2019. So we made more investments in 2020. And then you see the same kind of thing in the yellow box where you see things start to improve. And then in the middle of 2020, we started running into these problems again. You can see that with the pink line. And it got to a point after a number of engineers spent a month and a half coming up with a proposal for more investments. We were looking at the amount of engineering time we were going to spend trying to improve the system relative to what we thought the impact would be. And we got to this inflection point where we just no longer believed that the investments using the current approach were worth doing and that we needed to take a step back. And so I'll talk a little bit about the user experience and our takeaways from that 2017 up until that August of 2020 point where we decided to change approach. The general sentiment of our users really varied based on their role and their team and the common workflows they did. Going back to the 3 different types of GitOps use cases at Palantir, the internal infrastructure team has historically and continues to have generally a good experience using GitOps. I sort of classify their approach as a standard approach to GitOps. They manage, say medium size and sort of constantly growing number of tools and systems at Palantir, but it's still one team who's using it, and their experiences have generally been very positive. They find GitOps to be a huge leverage for them as a team. The second category around using GitOps for cloud infrastructure and getting to Kubernetes, the team initially started out being very intentional about using or limiting the user input surface area to minimize divergence across environments. And because they invested very heavily in automation up front, their experiences were very positive and added a lot of leverage for a number of years. And it wasn't until that single team that owned it we started sort of decomposing ownership across multiple teams, where the complexity of their GitOps approach started to increase quickly, which eventually degraded the experience and how much leverage it was providing. And then we also found is like users whose main focus was doing work in a single repo, their experience has always sort of been very positive. They had a very narrow set of things they cared about. GitOps provided a very positive user experience and allowed them to do what they needed to do very quickly. But it's sort of everyone who didn't fit into one of these categories, their experience as our usage of GitOps scaled sort of degraded in an inverse way. And there were three main themes to where we saw struggles. And so I'll dive into each of these three themes one by one. So the first of those is the limitations of Git, and maybe even more than just Git, it's the limitations of the tools that we were using to support the workflows that we needed. And so we at Palantir use GitHub and GitHub Enterprise internally. We think it's a great tool. And so this was the sort of interface that people were using to to engage and interact with our GitOps approach. They were using GitHub Enterprise, the pull request model, and so forth. And by the end of Q1 in 2020, some of the folks on our production engineering team were flagging that their team was having to regularly approve more than 500 pull requests per week. And if you just like do the math, it basically means that like one person is doing nothing but approving pull requests as their full-time job for like the week that they're on support. And a lot of the use cases we were having as our software continued to grow in complexity, we were looking to add additional services to the platform, and that meant opening hundreds of pull requests across all the environments to add a service, which meant that someone had to go in and manually approve each of the 100 pull requests, because we found it pretty hard to overcome or to do a better job of bulk pull request approvals while continuing to meet our compliance requirements for things like SOC 2 and FedRAMP and some of the other compliance regimes that Palantir as a company was pursuing. And so what this led to was just this general sentiment where it's just like death by pull request. The second sort of problem that we found with Git is, there's people who think YAML is the end all be all user interface, and then there's the rest of the world. And for those who were either new to the company or new to our system, what we found is like having YAML be the interface that you interact with the system with, there's a pretty steep learning curve on understanding where the YAML files are and which repos that you need to engage with, understanding the structure, how to make changes, what the common values were and so forth. And then if you were to make a typo or to make a mistake, actually debugging what went wrong is a really frustrating experience. And then finally, because of largely the repo structure we chose and the way our organization sort of laid over that, it was very important for us that we wanted to enable the right team to have permissions to make changes to the files that their team was responsible for. And so what this meant was us managing this complex mapping of which teams were responsible for which files in this repo structure, and then building automation that sort of added them as required approvers for pull requests when those files were changed. And we built something called PolicyBot. It's a GitHub application. We open sourced it a number of years ago. And this was the bot that was responsible for managing this. And the configuration to power PolicyBot on each repo would regularly exceed 10,000 lines, which meant it was so large that humans couldn't really reason about it anymore. So we built automation to manage that file. And then it was very challenging to reason about the automation and to make changes to it, because if you introduced a bug in the automation, it would have really dire effects. And so it just led to this world where nobody could really reason about how permissioning worked for our GitOps system anymore. And it was very, very complicated to change. The second big sort of theme we saw was it's wonderful to have a declarative source of truth, and Git provides a very sort of good version of that. But when your declarative source of truth disagrees with what you're seeing in production, it's very hard to understand why those two things don't line up. And oftentimes what that led to was users of our GitOps system having to open support tickets or Slack or email or Page, the dev teams who owned Apollo and owned the GitOps orchestration system. So we created this a really high interrupt working model. And what we found is like sort of, these, your target state and your observed state can disagree for sort of two main reasons. One is your GitOps pipeline fails in some way. And so for us, this was, GitHub Enterprise to Circle CI to Artifactory, and then Apollo would pick up the configurations from Artifactory and orchestrate them. And what that meant is that any sort of point along that pipeline, it could fail. And when it failed, it'd be very hard for a user to actually reason about why it failed. Will it eventually recover? Do they need to do something? And then what is the intermediate state that the system is left in? Because Git says one thing and production says another thing, and they don't understand why. The second category of things that could lead these things to disagree that we found is has nothing to do with the pipeline. The pipeline is operating as expected, but your source of truth is in one place, and the system that controls your actual software is somewhere else. Our Apollo platform allows for environment owners and team owners to define when change can happen. So you can define maintenance windows on a per environment basis, but also on a per installation basis. And Apollo will only allow a configuration change or an upgrade to go through when one of these maintenance windows, when you're in one of these maintenance windows. And the challenge with this is when your GitOps system and your source of truth says, oh, the configuration should be X, and that makes it all the way to Apollo, and Apollo says, okay, great, it should be X, but we're not in a maintenance window right now, so I'm not going to apply that. You have users who are looking at your source control system saying, well, right here, the configuration says it should be X, but it's not X. Why is it not X? And so they would have to go to a different system to actually understand why that's the case and reason about that and so forth. And so we're teaching users to do this, and was sort of a cultural journey that took some time. But then also the end state is you still have two different places you have to look to understand and reason about your system. And what we found that just really limits how good the user experience can really be. And because of this, anytime you run into problems, as I mentioned earlier, it led the users to have to go ask for help from the team who is responsible for the system. And that both sucked if you are on the team who's having to support this because your work is constantly being interrupted, but it also just doesn't feel good if you're a user of the system, you're constantly having to rely on someone else for a system that was supposed to be self-service. The final lesson that we came away with that is maybe the most important one is, in retrospect, in many ways, is the most obvious one. When we started our GitOps journey for our production systems, we chose to rely on the developer systems that we already had in place, GitHub Enterprise, Circle CI, Artifactory, and so forth, because it allowed us to get started right away. There are already these systems in place. We already knew how to use them. There was already tooling that we were familiar with. But unfortunately, those systems have regularly scheduled maintenance. It's very important that you patch those systems. Those systems may or may not be highly available or have online upgrades. And what we found is, even though our internal infrastructure team does an amazing job maintaining these systems, they do monthly maintenance. And every time GitHub Enterprise would go down for monthly maintenance, it would create a short-term panic when someone realized that they were no longer able to make changes to something in production because the dev system, the dev tooling system that we use for Git, was not available. On other occasions, and it was very rare, sometimes these systems have unexpected and prolonged instability, whether that's because an upgrade didn't go as one expected, or whether that's the infrastructure that underpins these things is having issues. But this did occasionally happen, and every time this happened, it created quite the emergency for us because we were no longer able to make and sort of actively make changes to our production systems and without using the break glass mechanisms that were in place. And anytime you're using those, it just makes everyone sort of on edge and uncomfortable. So when you're in those situations for long periods of time, it's really not great. The other thing for us was, because we operate our environments for highly regulated environments for customers who themselves are highly regulated, it's very important for us that we separate out the security boundaries for our internal infrastructure and how our employees use it from the security approach for our production systems. And what we found is, in relying on internal infrastructure systems to power our production infrastructure environments, it was very complicated to ensure that those two security boundaries never merged into one, and that we could continue maintaining the sort of security controls that we attest to in our SOC 2 and our FedRAMP, ATO, and so forth. And it just made everything much harder to reason about and make changes to over time. The final sort of part here was, because the internal infrastructure teams owned a set of the systems and the production infrastructure teams owned a different part of the systems, and those two teams were in different parts of the organization, they had different cultures, they had different priorities, and they had different expectations. And that occasionally led to sort of unexpected friction that just like it was hard to overcome because they were different organizations with different priorities. So August 2020 comes, we sort of get to this point where like, okay, we don't think the level of effort involved to continue improving the current system is worth what we'll get out of it. Let's take a step back and rethink how we want to do this. And so through that process, we had a couple set of goals. So the first was we want to keep the GitOps principles that we really believed in, largely that we set out, that we had when we set out, but we wanted to change the implementation. We no longer wanted the user experience to be limited by the implementation of our GitOps approach. Like we no longer wanted to be held back by, the pull request model of GitHub Enterprise and so forth. We wanted to provide a more tailored user experience for the GitOps workflows that our organization actually had. And part of that meant we didn't want to force users to engage with YAML as a user interface if it didn't make sense. Instead, we wanted to provide them an intent-based, outcome-oriented actions that they can take. And we wanted to align the change request workflow that teams spent a lot of time engaging in around something that mattered to their team. It should be team-oriented instead of being repo-oriented. And for us, in the GitHub model we had, everything was very much like repo oriented. And then we wanted to make it easier to make fleet-wide changes that required fewer manual actions so that people could actually use this in a self-service way without spending their time just approving pull requests. Third, we wanted a better permissioning model and approval model, something that was easier to understand, something that better aligned approvals and permissions with roles and responsibilities we had, something that wasn't file-based, but instead related to services and what we were actually managing. And then we wanted to get to a point where we can make context and content-based approval decisions instead of making file-based decisions. I'll talk more about that here in a second. And then finally, we wanted to provide more clarity around the difference between target state and current state, when those things were different, why they were different, and when they might converge, and do that through a single pane of glass. And so I'll show you a couple of screenshots of what our Apollo platform, the changes we made in our Apollo platform, just to give you a sense for what this looks like. So, one of the cool things we did is orient changes and reviews and approvals around a team instead of around a repo or a file. And so now, no matter which team you're on, whether you're an environment owner, whether you're a service owner that has services across hundreds of environments, you can have all of the pending and approved change requests through a single view. This gives us the ability of giving our users a way of sort of keeping them focused on what they need to do instead of having to look across hundreds of different repos. We gave people intent-based workflows. So now instead of having to go become an expert in the YAML structure of our GitOps approach, you can actually go in and say, I'm trying to add a new service, or I'm trying to add a new Helm chart to an environment. And when you click that, we can actually give you a workflow and a form that lets you fill in the information without having to guess at what the YAML structure is. But also, if you really want that, all of these things have APIs that underpin them, so you can still engage directly with the API if you want to. We kept a lot of the same workflow models in terms of the pull request, looking at the diff between the previous and other versions. We actually really like the pull request model of GitHub, but we wanted a better permissioning model, an approval routing model. So what you can see on the right is when you open a change request against something like configuration, we know which service owns it, who the owner for that service is, so we can automatically add them as the approver. But we can also do things like allow our InfoSec team to implement a webhook that allows them to make a contextual decision on whether they think the AppSec team should have to approve this decision or not. And so it's allowed us to become a lot smarter for when we require certain approvers or when different change requests can be automatically approved without being limited to simply who is the owner of this file, add them as an approver to the pull request. And then it's allowed us to provide much more coherent views in terms of the target state and the current state, and do so from a single pane of glass. So here you can see this is like what the configuration for a given service looks like. On the top right, it's like very clear that this thing is out of date. On the left, you can see the configuration history and the fact there were 2 pending changes for that. And then up in the circle on the top, you can see that there is a pending change for the configuration. There is an upgrade pending. And then you can click on the upgrade tab and you can we can tell you, yes, this configuration is being blocked for these reasons. It's not a maintenance window, and here's when the next maintenance windows are. So we can give a user a clear understanding of like both that things are out of date and when they can expect to have it become updated, or we can give you actions to actually add a maintenance window now and so forth. So these are just some of the things we've done over since 2020 to sort of improve our users' experience for GitOps in our production system. Our usage continues to scale. The graphs I showed only went up through the end of 2021, but the data continues to go up and to the right. And so I'll just leave you with a few key takeaways. I think every organization is different, and what your journey will be like and your user experience will probably be very dependent on the tools, technology, and sort of organizational decisions you make. But for us, these were some of the things that we sort of felt were most important. GitOps at Palantir looks very different for small teams than it does for platforms who have many different types of users. For us, the operational overhead of GitOps grew pretty steadily as the complexity grew, and both in terms of the number of products and teams we had, but also the number of environments we had. And that you shouldn't assume that the tools and approaches you take in GitOps that allow you to get started very quickly and get something up and running are going to be the same things, will be the right choice for you to scale your company forever. And then, the team that owns your GitOps infrastructure can very quickly become the bottleneck if the user experience you provide your users isn't self-evident. If they're always left with questions that they can't solve problems for themselves, it's going to create a very interrupt-heavy workflow for the team that owns it, and will likely become a burden on velocity. And with that, that is all I have. So I'm happy to take any questions that people have.
Great. Thank you so much, Greg. That was a super impressive presentation about your GitOps journey. We have already a few questions, but maybe we can start with one we received beforehand from one participant. So when it comes to, I guess you have a few hundred or even more than 1,000 engineers in your organization. How do you manage developer adoption and training for such a GitOps approach?
Yeah, I think it's a good question. So when we first started rolling Apollo out in 2017 and using GitOps, at the time, as a company, we already had tons of customers. I don't know how many production environments we had. And so we were sort of rolling it out into an existing footprint. And I think for that, we started with a single environment, proved that it would work, and then over time, slowly onboarded different development teams and then additional customer environments. I think at Palantir, the decision was made that this, I think initially very early on, say 2017, was something that we felt very much that we had to prove the value of. And so we spent a lot of 2017 and sort of early 2018 proving the value. But at some point, once it was proven, Apollo very quickly became the only means by which you as a software engineer could deploy software into production environments, and that all production environments would be managed by Apollo. And there's many reasons for that we can go into. And so then it became this exercise of like, well, how do you actually roll this out to everyone? How do you train people on how it works and so forth? And that took time. And I think different teams adopted it faster than others. But today, if you join Palantir today, this is like really the only thing that you'll be introduced to. And so it is part of our universal onboarding program. As an engineer at Palantir, you learn, you're exposed to this in like your very first week at the company and so forth.
Okay, cool. Thanks. We have some question. One from Sammy. Does Apollo have a service catalog, and is it configurable through YAML?
We do have a service catalog. So the sort of flow of information is every we call them products in Apollo, but it's basically as part of like the last step of your CI process. You publish your binary and your container image to Artifactory for us, which we use for our container registry. And then you make an API call to Apollo, which registers your product release with Apollo. And so Apollo tracks all products that are deployable into production and all releases of those products. And the default configuration for every product has to be registered as part of the product release, as part of the immutable product release. And so part of this is like we have sort of the separation of like your CI step, how products are built and how they are deployed. But then from within Apollo, we do track, these are all the services that are deployed. Here's where each release is deployed across which environments. And that's used pretty heavily by our engineers to understand things like version skew, where they're at in the rollout of their software and so forth.
Okay, cool. We have another question from Jamie. What were the key metrics you used to track your success?
Yeah, I think this is a really good question. I think for us, the part of it was getting to feature parity. So I think some of it was just like we could offer much better features than we could in beforehand. So some of it was very qualitative. There are things we do track, things like number of pull requests and so forth. That continues to be sort of an ongoing journey. I think, it's kind of a hard question. There's other reasons, organizational reasons, some of the decisions we made sense. Part of it has to do with like some of the complexity around the deployment models we have in hard to reach environments. So like there's many places we deploy into air-gapped environments. Those air-gapped environments don't have GitHub Enterprise and Circle CI running. And so if we want to have a consistent approach for how we deploy our software to those places, actually moving things to Apollo allowed us to deploy Apollo into those environments. And so those were honestly some of the key metrics, is making these changes allowing us to have a more consistent approach to how we deploy our software at scale. There probably isn't a better, more coherent articulation of the key metrics, unfortunately. There are things we're starting to look at now. We're starting to get to a point where it's like, okay, are we able to drive down the mean time to merging pull requests? Are we able to reduce the number of button clicks the user has to make to do bulk approvals and so forth?
Okay, great, thanks. We have two more questions. I guess they are around Apollo itself. So how much custom development is required to get to such improvements, and how far this is built up on existing tools you have been able to reuse. Could you tell us a bit more about that?
Sure. Yeah, so Apollo, we have the Apollo engineering team is probably 25 people. And so we already had a team in place that was doing this. We built Apollo in-house starting in 2017, primarily because at the time there wasn't something that was really going to solve our problems for us. So we did already have an engineering team in place. We did already have sort of a large code base. We did already have Apollo. So a lot of the work that we were doing to solve these problems were sort of building out pull request workflows in the context of Apollo. And a lot of the tech stack for Apollo already existed. It's built in the same tech stack we build our other products and platforms on. So a lot of that was already in place. This wasn't us starting from zero, but it was a very meaningful effort involved. And we ended up building a lot of tooling to both keep a view of the configuration in GitHub, so keep syncing back and forth so that people who are used to seeing stuff in GitHub continue to do so while we move their workflows into Apollo itself. So yeah, I don't know if that quite answers your question. We were building on top of a pretty mature tech stack already because we already had that with the Palantir tech that powers Foundry and Gotham, and we already had an engineering team in place who were already building Apollo.
Yeah, understood. But so Apollo itself, it's really something your engineering organization developed more or less on their own.
That's right. Yes, we developed it. I think Palantir's deployment landscape, our business has always sort of deployed our software to where our customers were. We got our start working with the U.S. government, and there are a lot of companies who just weren't comfortable with the cloud, and so we had a pretty unique deployment scenario. Over time, I think our deployment scenario has become more and more common But when we started building Apollo, we built it because nothing on the market or in the open source space in 2016, 2017 really was able to address those problems.
Yeah, fantastic. Great. We have, I think, one more question that was around the monitoring dashboards. I guess you showed some, how they have been created. That was another answer.
Yeah, so early on, up until recently, 2020, maybe early 2021, the two things, like how we create monitors and dashboards, were pretty disjoint from how we did GitOps. We use Datadog as a company for observability, and so engineers would go in and manually create their dashboards and their monitors. And then what we found is actually this is maybe obvious to people. It took us a little while to get there, but it's really valuable to have your monitors and your dashboards tied to your release process and sort of like exist, especially when you're doing continuous deployment. Having your monitors get updated as new versions roll out is pretty important. So one of the teams built that into our production infrastructure into the Apollo platform. So today, most of the monitors at least are deployed, they're defined with the products themselves, and they're like the source code repos for a service. And then they are created and maintained by Apollo during the upgrade process. Okay. Dashboards aren't like that today. That's just monitors. Dashboards are still sort of maintained elsewhere.
Yeah. Okay, great. If we have time for one more question, I would have one. You tackled this issue with that YAML files don't provide the best user experience or dev experience, and then if I understood it correctly, you built some layer on top. Can you maybe share some insights with the audience how to find this right level of abstraction, because we know this is an ongoing debate in the platform engineering community. I guess a lot of folks are interested in.
So I'll just come back to, I can give 2 examples. So this is the screenshot I shared. So actually I'll start here. Sorry. Okay, so like you can sort of see, this is the file here on the left is actually is an example of the YAML file that people had to go in and modify before. So this is like how we would define a static asset. Yeah. And like it's not super intuitive, if you can see. This is a kind of complicated YAML. And so what we did is we ended up moving the YAML. We actually maintain a lot of the state still in YAML form. And that allows power users to go and like they know how to edit this thing. They just want to give them a text editor or give them a CLI or something. They can still do that. But then what we were able to do is say, okay, but actually a lot of people don't want to do that. And so we know how to generate the 8 lines of YAML that need to exist in this YAML file. Yeah. And so we can give people a more workflow-like thing, put them on Rails if they just want to say like, cool, I don't know what I'm doing. Let me just add a service. Let me fill out some fields. And then on the back end, we can actually just generate the chunk of YAML and insert that into the right place. And it gives sort of the best of both worlds. It gives the power users, the people who just want YAML, who just want to interact with these things via API or whatever, they can retain that optionality. But it gives everybody else, you can sort of give them these like workflows that automate that for them so that they don't have to like always understand how to do this. I think this approach has been very productive for us. I think this has allowed us to do a bunch of like, really improve the user experience in a lot of ways. It's also allowed us to like minimize the human error that you oftentimes find, because like someone had a comma instead of a period, and like that's actually just very hard to see in a text editor and so forth.
Yeah, great. That makes a lot of sense. Cool. Maybe one very last question, and then I think we'll wrap it up. From Jesse, do state changes in Kubernetes update the YAML files in Git?
It's a good question. It gets kind of in the weeds of how Apollo works. The answer, for at least for us, is no. The answer for us is no. That doesn't mean like I think if you wanted to, depending on the continuous deployment system you had, like that kind of approach, I think is certainly a reasonable way of doing it. We try to Apollo tries to have the YAML files that we're managing not include things like version numbers of container images, but that sort of gets into the details of Apollo that are maybe irrelevant for the conversation of GitOps. But I'm happy to discuss more if folks are interested in that. I'm on the platform engineering Slack. So if you are, feel free to Slack me about those kinds of things. Happy to discuss.
Okay, great. Thank you. Then I would say we wrap it up. It was really a great meetup. Fantastic presentation, Greg. Thank you so much. For the audience, don't forget to join our next webinars and meetups. So we have Nathan Yellin next week, August 11th. We have Brian Finster, who was involved building the platform at Walmart, August 23rd. That will be great. And we also have Victor Farchis about what really is Kubernetes on August 25th. Okay, sorry, great. Yeah, thank you so much. Thanks everyone for joining. And yeah, see you soon. And we will share slides and more materials in the follow-up email tomorrow. Have a great day. Have a great evening, everyone. And thanks, Greg, again. Bye.
Thank you all.